Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, this is a continuation on the stoichiometry and the mole concept. And for the very first time, we are moving onto the mole calculations of this particularly big topic. So far we have done chemical formula, balancing chemical equations, we've done empirical and molecular formula, and all those relative masses. Now it's time to combine all those concepts and move further into mole calculations. And we're going to be thinking about this constant called Avogadro constant, named after the guy, a chemist living thousands of years ago by the name of Avogadro. Okay, so in this particular learning objective, you'll be learning to state that the mole is just a unit of amount of substance. So a lot of students get confused about what mole actually is. So mole, MOL is the full word, MOL is the unit, is the abbreviated unit of this quantity. What is important is it's just like a counting unit. So it's just an amount of a substance, and what is happening is that 1 mole, when we talk about 1 mole, we have 6.02 times 10 to the 23 particles. And the fact that we have this thing called particles here, it could be atoms, it could be ions, could be molecules. We don't know which one, but it could apply for each and every one of these. For particles here, which could be this, or that. Now this number is very, very important. You will not be given in an exam. I assume you actually need to know this particular number, 6.02 times 10 to the power 23. 10 to the power 23 on your calculator actually means that there is 23 zero after that. Okay, so to give you an idea, so 1.0 times 10 square basically mean 100, because you are moving the decimal place by 1 and 2. So if you have 1.0 times 10 to the 4, you are moving the decimal place 4 times to the right. If you have 10 to the 23, you're doing that for 23 times. That is how big this number is. That's how big this Avogadro number is. And when we think about the actual number of particles, be it atoms, ions, or molecules present, it's such a big number that we don't really want to be thinking about such a big number. We simplify it by talking about 1 mole. Every chemist has the same language throughout the world. 1 mole basically means Avogadro's number of particles. We're going to use the relationship, the amount of a substance, which is basically the unit. Mole there is basically the definition of mole is mass over mR. So this molar mass is in gram per mole, is the mass for 1 mole of the substance or of a substance. And this is given by the relative atomic mass for an element, or mR, which could be relative molecular mass for a compound. But then remember that in the syllabus, year 9 syllabus, in relative masses, we said that we can use relative formula mass for ionic compounds. The way of working on mR is the same for ionic compound or covalent compounds. It's just sum up the individual as well as the total. Sum up all the relative atomic masses for all the atoms present. They were from your atomic structure syllabus. They were also from your states of matter kinetic particle theory syllabus. They were also what we covered in the few lecture tutorials ago under this particular stoichiometry topic. Mass over mR or mass over AR was something you had done when we did empirical formula. As you could see, the unit cancel each other out. Very important that you could follow unit because it's a primary school mathematics. So what we're going to see here is this is giving us mole, which is basically what we want there. Mole equal to mass over mR. Now we're going to use this same formula to calculate the amount of substance in mole if we have these two information. But how about if you want to calculate mass? If you just want mass, then you just move this up there. So you're going to get mass in gram is equal to mole times mR in gram per mole. This is just rearrangement of formula. How about if you want to find molar mass? If I want molar mass, I move up molar mass, then I move up the mole at the bottom. So if I have these, then what is mR then? I don't want to be remembering so many formulas. So mR is just going to be equal to, move this down there because I'm going to divide both sides by mole. So there's just mass over mole. Okay, and what else do I have? As you can see, mass over mole, gram, mass in gram divided by mole in mole. And then relative atomic mass or relative molecular formula mass, that is just the mR. That is pretty much the same as this molar mass there. C and D are pretty much the same thing. and then the number of particles. So whatever you do, always work out the number of mole first. So once you get the number of mole, then you can just multiply by the Avogadro constant, because once you have the number of mole and you know that you have Avogadro's number of particles in 1 mole, so however many mole you have, you multiply by the Avogadro constant, will tell you the actual number of particles there. Okay, so just a brief overview of what we have done so far. A mole is defined as the amount of a substance that contains the same number of units as the number of carbon atoms in 12 grams of carbon-12 isotope. So this carbon-12 isotope came up before in your year 9 syllabus under atomic structure as part of your definition of relative atomic mass, where you need the carbon-12 isotope as your reference standard. Similarly here, this must contain the same number of units as the number of carbon atoms in 12 grams of carbon-12 isotope. So this is 1 mole contain Avogadro's number of particles. L is the generally accepted international symbol for Avogadro's number, 6.02 times 10 to the 23 there. Mole is equal to mass in gram divided by molar mass in gram per mole, and you can rearrange this equation if you do the mathematics correctly, which you should be able to, because rearranging equation, algebra is your lower secondary mathematics, is also something you might have done in primary school mathematics. Okay, so let's put this into practice. We're going to be looking at a couple of these problems. So if we have the first one, we have chlorine atoms. For the second one, we have chlorine molecule. Chlorine atom is just Cl atom. Chlorine molecule is CO2 molecule, as this diatomic chlorine, which is incorrect because you got to draw all your outer shell electron. That is from your year 9 structure and bonding concept. So for the first one, if I have 1 mole of this chlorine atom, what is going to be the mass? Pay particular attention to the atoms. So we're talking about the AR of chlorine atom, which is 35.5. So what do we know? We know that mole can be represented by N. N is basically mole. So basically I could do mole equal to mass over AR here, because I just have the atom. So I want the mass. So mass equal to mole times AR. So I have 1 mole according to the question. I have my AR, which is 35.5, so the mass is 35.5 gram there. So 1 mole of chlorine atom is 35.5 gram. How about the second one? So I have molecule, so I have a diatomic molecule. So what I have is mass over mR, because this is for molecule now. Same deal, so mass equal to mole times mR. What is my mole? N is the international accepted convention to write mole of something. So the mole of chlorine molecule again here is 1 mole. So if I have 1 mole, multiply by the mR of Cl2, something you had done previously. There are 2 chlorine atoms, so I do 35.5 times 2, which is 71. So the mass is 71 gram there. Okay, so I'm just going to move that to the other side so that I have some space there. How about part C? I have 2 mole of oxygen atom. So we know that mass equal to mole times AR there. I'm not going to remember all of these. I just need to remember mole equal to mass over AR, then mass equal to, bring up the AR, multiply by mole there. So I have 2 mole of oxygen atoms, so 2 mole. I have oxygen atoms, so the AR, relative atomic mass, for the element is for the atom, so there's only 1 oxygen atom on its own, so it's just 2 times 16 there. Do not forget unit. Unit is everything in your physical chemistry, especially when you do calculations, and these are mass. As you know from physics, mass have unit. If you don't include the unit, you are going to make a huge mistake. Okay, so mass equal to the mole times the mR there, because you're talking about molecule. So you have mass equal to 2 mole of oxygen molecule, which again exists as this diatomic molecule. As you know, they form a double covalent bond because the group 6 element want to share 2 electrons, 2 out of the 6 valence electrons, to complete the outer shell there. So we have the mR of O2 being 16 times 2, which is 32 gram per mole. Okay, so what is our MR there? It's going to be 32 because this is for oxygen molecules. So So 2 times 32. So the mass is 64 gram because this is for 2 mole of oxygen molecule there. Okay. Next one, we're going to calculate the mole based on the masses. As we know about aluminium, it's a metal, it's a group 3 metal. They just exist as like that. Calcium carbonate, as you know, calcium 2 plus, CO3 2 minus. The valency being 2:2. When you do the crisscrossing or the cross multiply, you're doing lowest common multiple. You want the simplest whole number ratio. Therefore, it's going to be CaCO3, where the +2 charge cancel the -2 charge when you have one of each of these ions. However, when you have ion 3 plus and SO4 2 minus, your valency is 3 and 2 respectively. So you got to do your lowest common multiple, which is what you get when you do the crisscrossing or the cross multiply. And lowest common multiple is basically LCM, something you had done in primary school mathematics. -2, -2, -2, cancel out +6 altogether. Your formula is going to be 2 of that ion 3 plus, and then bracket for the polyatomic ion, you have 3 of that SO4 2 minus, and therefore there's the formula for iron 2 sulfate there. Iron 3 sulfate, I beg your pardon there, okay? So what we're going to do is, we're going to be looking at the AR. So from the periodic table, the relative atomic mass of aluminium is 27. And then I'm looking at the MR, calcium carbonate. So there's 40 times 1, plus 12 times 1, plus 16 times 3. So they give me 100. And last but not least, this MR Fe2, SO4 3 times. That's how you read it. And what do I have? I have 2 of iron. Each of iron is 56. And then I have 3 lots of this sulfate. So 3 outside. I'm going to put a big bracket. I have 32 times 1 plus 16 times 4, and then close the big bracket. This is what you need to be able to do from your relative mass tutorial, from relative molecular mass lesson. So I got 96 there, multiplied by 3 because I have 3 of that sulfate, plus 56 times 2. I have 400 for my relative molecular mass there. Okay, so what we're going to do for part A, mole equal to mass over mr or mass over ar if you want to, because it's an element. So you get 8.09 divided by 27. So just pressing that onto your calculator, I get 0.2996. Looking at the data, this is 1 significant figure. This is 2 significant figure. This is 3 significant figure. You have learned significant figure in lower secondary mathematics. You know that based on the data given, you should always have it to the significant figure as presented in the data. Okay, so this is 1, 2, and 3. Therefore, we look at the fourth one. So the fourth one is more than 5. Therefore, you add 1 there. But 9 plus 1 gives you 10. So you add 1 more there. Same deal, you add 1 more there. It becomes 0.3. There is 1 sig fig. This is 2 significant figure because 1 and 2, you don't count the 0 in front. This is 3 significant figure. Do not forget your unit. It's just physical chemistry. It's just physics. Okay. So mole equal to mass over mr, mole equal to 25.0 divided by 100. Your calculator will show you 0.25. That is not going to be good enough. Look at the data 1, 2, and 3 significant figure. If you have 3 significant figure, it's not your calculator that cannot think. It is just that it's not that your calculator doesn't want to think. It can't think, right? Okay, I mean, it has to. It's following your action as the user, as the human being. Okay, so the mole equal to mass over mr for part C. That's going to give you 279.9 divided by 400. So here I get quite an exact answer actually, 0.69975. Looking at the data, 1, 2, 3, and 4. So there's 4 significant figure. I should follow the data presented in the questions, especially when the question doesn't tell me how many I should run up to. So I'm looking at 1, 2, 3, 4. So this is more than 5 or greater, so that will be 0.6998 mole. This is to 4 significant figure. Here in this question, we have 3 moles of ethanol. We know that mole equal to mass over mR. I should really put this down here. We have the mole. We can get the mR from the periodic table by calculating or by totaling up the relative atomic mass for however many atoms we have. But we want the mass, so let me just do mass equal to mole times mR. Because I have moved the mR up there, what I've done is I multiply mR on both sides, so it becomes mole. Mole is represented by N internationally, multiplied by mR, and then this multiplied by mR get cancelled out. You're just left with mass on one side there. This is called rearranging equations, primary school algebra, lower secondary mathematics as well. So we need, very importantly, we need the mR of C2H5OH. We can see that there are 2 carbon atoms, so there's 2 times 12, which gives us 24. Altogether, we have 5 hydrogen plus 1 hydrogen. We have 6 hydrogens, so there's 6 times 1. And I also have 1 oxygen, so 1 times 16. So that gave me 46. So that is your syllabus basically on calculating the mR earlier, just before we did mole calculations, right? So we have the mass here. We have 3 mole according to the questions, 3 moles, and we have the correct mR because we know how to sum up the relative atomic mass correctly. So these are mass in the mole equation. The mass has to be in gram, as this is in gram per mole, to give us the mole as mole. Okay, so 3 times 46 give me 138. And don't forget the unit. If you forget the unit, unfortunately, you're not going to score anything at all, or you might lose some silly marks along the way. This is physical chemistry. Just like in physics, if you don't have units for physical quantity, it doesn't have a meaning whatsoever. Okay, so now the next bit is nitrogen. If a question does not mention nitrogen atom, it simply means it must be nitrogen molecule. So it has to be this diatomic triple bond nitrogen, which is still wrong because you know about dot and cross show all your outer shell electron. Each nitrogen atom has 5 outer shell electrons. Therefore, you started with 5 in outer shell. You just need to share 3 more to give you this really strong triple because 3 covalent bond there. So we need to work out the mR of N2. That's how nitrogen exists, as this 79 or 78% of nitrogen in your percentage composition of the air, which is a mixture of gases, right? So 14 times 2, which give you 28. So we know that mole equal to mass over mR. We need the mass, which is mole times mR. So the mass is 0.150 mole. Multiplied by the mR from your periodic table, which is the mass for 1 mole, so it's gram per mole, multiplied by mole, giving us the mass in gram. Oops, 0.150 times 28, that give me 4.2. I need to be careful. I need to know what is appropriate number of significant figure. Calculator cannot think. It has to be up to the user in order to think about the data provided. 1 sig fig, 2 sig fig, 3 significant figure. Significant figure is in your mathematics case study, in your mathematics syllabus. So, you know, your calculator show you 4.2, that is 1 and 2 significant figure. It is not appropriate because it depends on the data in the question, just like in practical studies. Okay, next one is calcium phosphate. Calcium phosphate consists of calcium 2 plus and PO4 3 minus. Now we know about exchanging valency. So 2 and 3, when you do the crisscrossing, you are doing cross multiply in order to cancel out the charges. So I'm running out of space here, but 3 goes there, 2 goes there. So the formula is going to be calcium, 3 of them, and then you will have 2 of this phosphate. No one will be there to provide this formula of ions for you. You have to know all the ions present in the table, especially for this difficult polyatomic ion. At least group 2 metal, you can still get it to be calcium 2 plus that. The purpose is to combine the ions, however many there are, so that the charges total up to cancel. Plus 2 times 3 is plus 6. Minus 3 times 2 is minus 6. Your ionic compound, despite containing ions, overall is uncharged there. So the mR of this particular compound there, 3 calcium, so 3 times 40. I got 3 of that phosphate. So 1 times 31 for 1 phosphorus, 4 times 16 for the 4 oxygen, but the whole thing, the bracket has to be multiplied by 3. We did this when we covered chemical formula. We did this when we covered how to work out MR for this kind of formula with the number having a meaning at the particular level. Okay, this number at the bottom, they have a particular meaning. I think I've gotten this one wrong, by the way. This should be PO4 twice. That was my mistake because we already seen that there are 2 of these phosphates, so there should just be 2 of them there. So no wonder it looked a bit funny just now. So there was 120 plus 2 times bracket 31 times 1 plus 16 times 4. You need to be careful when you do this kind of calculation. You cannot afford to make any mistake at all along the way. Okay, so mole equal to mass over mR. I need the mass in the question, so that's the number of mole. According to here, 0.710 multiplied by the mR, which I just calculated correctly, hopefully without any mistake. And they give me 220.1. Looking at the data, this is also 3 significant figure. So my calculator cannot think. I have to be able to think on behalf of my calculator to give it with the unit as well as to the correct number of significant figure there. Okay, I think what I'll do here is to actually just stop at this particular question in this particular lecture tutorials, and there's actually a bunch of other questions in the lecture notes that you should really go through yourself first. As with any mathematics kind of questions, it takes practice. You don't just read it, you don't read mathematics. Instead, what you do is you gotta practice through the method and also work through the calculations yourself. Okay, so I'll see you in the next lecture tutorial where we will continue the rest of these problems. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry, that's at ptet.chemistry, across all the popular social media platforms to get connected.